Hey folks, you're listening to the Java Easily podcast, episode number 4. Java Easy. News, tutorials, tips. Everything you need to know as a beginner Java developer. Now, just before we get started, if you're completely new to Java and you haven't yet grabbed your Java Beginner Starter Kit, which is available on our website, just hop along over there. It's javaeasily.com on the homepage, and you'll be able to grab it and download it from there. It's completely free, and it's designed for complete and absolute total beginners. Super helpful guide that's just going to help you get up and running with Java programming really quickly. So in this episode, we're going to have a dig in really about how we can get started with object-oriented development and design. So in the Facebook group, as you know, we give questions which people can answer, which helps us basically establish what kind of content we might want to do to better help people out. And two of the questions are, I forget exactly what they are, how they're phrased now, but it's pretty much like, what area do you most struggle with in Java is one question. Another one is, what would you most like to improve? Something like that. I forget exactly what it is off the top of my head, but it's something like that. But anyway, the responses I get, like I say, we use to work out what kind of content we're going to do. At least that's how we're going to do it going forwards. And in fact, the first few episodes of this podcast have been driven completely from answers to these Facebook questions. And so in this episode, we're going to look at one of the answers that I got. And if I pull it up now, so I've got it in front of me. Oh yeah, here we are. We've got the exact thing now. So the question number 1 is, what's your biggest barrier to getting where you want to be with Java right now? And the answer we're going to look at in this episode is learning OOP, so object-oriented programming. And the second question is, at the current time, what's the thing you struggle most with right now in Java? And the answer for that was inheritance. So what's good about these answers, for me personally, is it gives me a little kind of like ping of nostalgia. Because I always think about, how did I first get on when I was a Java developer, when I was doing Java for the first time and just getting to know it, and what kind of areas did I struggle with. And so in this episode, we're going to look at this idea of object-oriented programming or object-oriented design. So how do I tackle object-oriented design now as a Java developer who's got more than 20 years experience in Java? Now, if you ask that question, or if you think about that question, you're probably imagining that, all Java developers who are kind of seasoned professionals, we go around on whiteboards and we, metaphorically kind of like chalk up UML diagrams and discuss different interactions of objects and that kind of stuff to be able to flesh out a design. In other words, how the objects are going to interact in a system. And a precursor to that, of course, is actually working out what kind of objects are you going to have in the system. So in other words, what classes you're going to have. That's the so-called domain-driven design, which is where you're working out how you want to describe the problem and the solution to the problem in terms of the actual classes that you might write to be able to derive this domain-driven design. And so you probably imagine that that's kind of, pretty much like what we do. And to be honest, it's not. It really isn't. If I start out as, designing something completely and totally from scratch, then invariably what I do is I work out the smallest possible unit to do what needs to be done. So, for example, if it's creating a report and the report has to be in some kind of PDF format, or maybe it has to be in Excel beforehand, then you generate a PDF out of it, whatever it might be. The first point of focus that I'd have on that design or that kind of like coding task is purely to pretty much stick everything in a public static void main method and only put in the actual commands that need to do what I need to be done in that method. Not even thinking really about how to even break it down into different methods at this point, let alone how to decompose it into different objects. That comes much later on. But before you do anything, before you can evolve an elegant OO design, you first of all need to kind of like get the absolute bare minimum, the absolute essence of what it is you're trying to do into the smallest possible conceivable unit, which is a method. And also, by the way, as well, it's nice throwing things just into one method and not having to worry about OO design up front. Because if you do that, if you put everything just in one method, then your focus isn't distracted on how to decompose different calls amongst different objects, and how trying to work out about how those objects are going to interact. You don't have to worry about anything like that. You're just basically saying, okay, I've got my pom.xml file if you're using Maven, or a build.gradle if it's a Gradle based build or whatever. You work out which dependencies you need, throw the dependencies in there, set them up, get the imports set up as you're actually coding, or rather making calls to the different libraries that you need to use to be able to do whatever it is you need to do. So for example, in the case of doing this kind of fictional report things, maybe I'm including Apache Poi, it used to be Jakarta Poi, which is the library for dealing with Microsoft formats. So it gives you an ability and an API basically to work with, for example, Word documents, PowerPoint presentations, and also, in this case, Excel spreadsheets. So as part of that, you're going to have API calls you're going to make to this library about how to navigate the workbook and the worksheets and all that kind of stuff, and how to put whatever cells you want to put in and whatever rows and formulae and that kind of stuff. So yeah, so maybe you put Apache Poi in there first of all to be able to do that aspect and generate the Excel spreadsheet. That's one part of it. And then the part afterwards where you want to generate a PDF. Again, there are different strategies of being doing that. And again, you'd work out which library you want to use for that particular use case and throw it into this main method. And the nice thing about this is you're basically working at the absolute bare minimum. So you're working purely at the most basic level of how to assemble these calls together when you're using these third-party libraries, which, to be honest as well, most of the times when you're using third-party libraries, they're not exactly intuitive to use, and they have a lot of kind of complexity and mental baggage that go along with them. So in fact, it's really freeing just, not thinking or not even worrying or concerning yourself with object design up front, and purely trying to assemble together the raw moving parts, the minimum viable product, if you like, set of method calls to these libraries to be able to get done what you need to have done. And at that point, once you've got that method, which does what you need it to do, and you've worked out how the integration with the third-party libraries are going to work, at that point, you've got, like I say, the base level, the kind of essence of exactly what it is you want to kind of distribute into some kind of nice OO model. You've got that concentrated in just one place. And at that point, what I'll typically do is I'll make a copy of the project, create like a quick zip file of it, for example, so jar CVF to be able to create a zip file or jar file, or otherwise what I normally tend to do is I use Git. So when I first start a project, as soon as I create the project from the outset, so in Maven's case, for example, if I'm using Maven archetype generate to maybe generate a project out of the quick start archetype, then once I've got that base level project created, I'll just do git init in the root of the project. That'll basically put the .git folder in there, so allow me to do basic version control locally in that project. Then I'll do git add dot to add everything in there, and then git commit -m, and in quotes just put a message like initial import or whatever. And I'll sort out the git ignore and everything a little bit down the line, because I don't want to be distracted with anything to do with that kind of stuff from the outset. All that kind of tidy up stuff, or that evolution into, like, let's say, quote unquote, a proper design, that can all come later on in the process. But you've got to really focus on exactly what it is you're doing at any one given point in time. And the first kind of like embryonic phase of the design and development of a new piece of code, at least if it's in like this kind of like prototype or proof of concept type stage, is to not concern yourself with anything like that. Just basically get like a quick project together, dragging in the dependencies that you need, finding the sequence of calls that you need to be able to do what you need to have done. And then at that point, like I say, you can either then choose to either zip up the project and just to kind of archive it off, just so at least you have a kind of like a first draft version of what the most raw kind of MVP version of code is. Or if you're using Git like I do, you can then just do another commit to add all the changes that you've made up to that point to get to this kind of like embryonic form of the code that you're working on. Now, at this stage, of course, we haven't spoken about objects, really, apart from the fact that we've just kind of said we sort of defer that at this stage. So then how we get from this embryonic project stage to an OO design is that we're going to first of all take the method that we've got, which is in this main method, and maybe we break it out into its own class, and the class name describes the use case of what that thing's doing. So for example, maybe it's a kind of like a report generator, for example. So we create a class report generator, and then we're going to migrate that method, or the bulk of the code that's in the main method, push it out into a method inside the report generator class. And at this point, the method's going to be static because there's no state that we've put into that class so far, or into that object. Because remember, everything was just going to be inside a main method initially. So that means that all of the variables and everything that we might need would be scoped inside that main method. And given the fact that we're taking the code from that main method and putting it into its own method inside a new class report generator, then at this stage, all we're really doing is we're wrapping up the existing code that we have, and we're just putting it inside a class that kind of is named representational to what it actually does. But at this stage, though, it still isn't a proper object because it doesn't actually have any state. And that's because the variables which are inside the main method, they were also just migrated along inside the scope of this new method. So maybe report generator has this new method, generate report maybe, or maybe it's just generate because it's kind of implicit that it's generating a report because the class it's invoked on is called report generator. So at this point we've really just done kind of like an organizational task of like moving the code across to something that sounds like and is described like what it does. And it's really just a finger in the air at this point about what we're actually going to call this class. It seems to generate a report. It seems sensible, therefore, to call it report generator, which is okay. So at that point then, though, you might want to start thinking about the actual scope of what's inside this method. So, in other words, what this method is trying to achieve, is that just kind of like one thing? Or is it kind of like many things? And that might seem kind of abstract. But what I mean is it's really linking it sort of going kind of in the direction of this like single responsibility principle which we have in our design, where we want to make sure that an object, or rather a class, knows how to do one thing and one thing very well and only one thing. And this is kind of notion of this like single responsibility. So in order to get to this kind of like single responsibility principle, or SRP as it's sometimes called, which is the acronym for it, it makes sense therefore to take the method that we have, which is maybe like a bit of a monster method now at this stage because it's doing several different things probably in all reality, and we want to start breaking it up into the different kind of functional areas or the different functions. In fact, what we're really doing now, if you think about it, is we're almost breaking it up kind of like in a procedural kind of way. It's not strictly speaking procedural though. So it's not, for example, that like, you know, if you've got a method A, can you robotically decompose it into methods A1, A2 and A3, where A calls A1, then calls A2, then calls A3. It's not really like that. It's not as mechanistic as that. It's more about breaking that method up into functional areas where we kind of think that they're going to be suitably different from each other in terms of the type of calls they're going to make, in terms of the libraries they might invoke, and in terms of the data members or the data state that they might need to work with. Seems a bit abstract, I know, but just bear with me. So for example, this report generator class with its one mega method, we've said so far that in principle it does pretty much two different things. It generates an Excel spreadsheet and then it creates some kind of PDF report afterwards. So that means that at the very least, we'd probably want to split it up into those two different functional areas. So we break it out at that point into two different methods, which would be generate spreadsheet and then render PDF or something like that. Whatever it might be, it's not too important, but we have the notion then of the two different tasks which are called by this report generation routine, which is effectively what it is, as being two functions which are kind of pretty discrete from one another. So, for example, the process of creating a spreadsheet, or generating a spreadsheet, creating a spreadsheet, whatever you want to call it, but the process of doing that, it's going to interact with the Apache POI library, because that's the library that knows how to create Microsoft XLSX files, so the Excel spreadsheet files. It's not going to need to know anything about PDF generation or anything like that because that's not its business. Its business is really being able to take some data from somewhere and then create a spreadsheet out of it. And which, by the way, at this point, we then start to think, do you know what, we've got an extra aspect to this as well, and that's the fact that we need to have some kind of like data input into this class or object, or at the very least this method. Something that might lead us down the path of saying, okay, we need to create an extra class now to be able to source the input data, so to be able to read the data, which is then passed into this spreadsheet generator or spreadsheet creator, whatever you want to call it, into that method as its data input. And it's about thinking about these kind of, the kind of different tasks that a class would have to do and the responsibilities or the functional areas that it would kind of be involved in, whilst keeping in mind this kind of like separation of concerns sort of principle to make things, to give them kind of like a single responsibility that leads you down this kind of thought process of saying, okay, well, yeah, we need to, create another class for that because that's a different kind of thing we need to have done. So we started out initially with just two different functional areas, generate a spreadsheet, then generate the PDF. And thinking about the first aspect, generate the spreadsheet, it became apparent that we also need to have a mechanism to get the data in to this kind of spreadsheet generation routine. So therefore we're starting to think about, okay, well, maybe we need like a class to be able to load this data as well, because that's a different functional area too. Because loading data isn't really related to creating a spreadsheet. And in fact, even having them as different objects or different classes enables you to be able to swap one out for another implementation at some stage later. So for example, maybe one day we read, the data in some kind of XML file and then pass that kind of data chunk to the spreadsheet generator. And then sometime later, we decide we don't want to use XML for whatever reason, the input formats change, or we want to consume data from a different type of data source. Maybe it's actually a database this time, or the NoSQL database, or whatever it might be. Then that's okay. We can just basically write a custom implementation of this. Let's give it a name now, this like data reader. Yeah. We create a custom implementation of this data reader, then to not be an XML-based one, but instead to be, for example, a database one. Now, as long as you have interfaces involved, whereby the parameter that's passed to the spreadsheet generation routine is given in terms of an interface, then it means that this spreadsheet generation routine doesn't really care whether it came from XML or whether it came from a database, because it's just calling internally methods to get the data which are defined on that interface. And as long as those two implementations implement that interface, then it's okay. It means we can adapt the system to change. So one day it's XML, that's fine, and the next day it's a database data source, and that's fine too. We're kind of jumping ahead a little bit here, really, but that's just to give you kind of like a rough indication of where you might want to use interfaces as well. So that's so far the reading of the input data and the creation of the spreadsheet, those first two functions. And then the next function we'd probably have is this, creation of a PDF. So whether you want to say you're rendering a PDF from the data, you're creating a PDF, whatever it might be. But again, we'd want to have a kind of a class then for creating a PDF. So at this stage, just to take a step back, to summarize where we've got to so far is we pretty much stuck everything in a main method. So we created a blank project, we gave it a public static void main method, so the default method in Java. We put the minimal set of dependencies in that we needed to do whatever we wanted to do, which in this case was creating a spreadsheet and creating a PDF. We then created a class where we could ship this kind of like mega method into, and we named it sensibly, so we called it report generator and gave it a generate report method or whatever it might be. And then in order to kind of go down towards how we actually evolve that into an our design, we then started to break that method up, first of all conceptually inside our heads, into the discrete kind of functions or functional areas that it was doing effectively, which at first sight was just two things. It was basically creating a spreadsheet, and then it was creating a PDF or generating a PDF. But then in doing that, we also discovered that we needed to have some kind of input reader or some means of input, or grabbing the data that we're going to use as input into the to pass to the spreadsheet generation routine. So that gave us like a third concept. So at that point then, we put those in three different methods. But in putting them into those three different methods, things would probably start to get complex, because we're really then going to have to somehow transmit the state across the different objects. In other words, like in terms of actual parameters to the methods that you've defined. So at that point then, we'd probably start to think about, okay, well, let's not just have the variables inside a method. Instead, let's actually think in terms of objects and separate the data that we have into either data which is associated with an object. In other words, if these objects have state, we start to think about those kind of things. And in doing so, then we're going to put member variables in to those classes to be able to hold on to that state for the given objects. And we'd separate that notion of state from state that's kind of like internal to the method itself. So this means at the very base level, we're going to have this one class, report generator, with its one method to generate report. We're probably going to have three different classes then, which house the different types of functional things we're doing, which is namely, reading the input data. So let's call that an input reader, or data reader, or whatever you like, or data set reader, maybe, data set reader, or data set input. Actually, it could be whatever you want to call it, really. It's very difficult to name a concept until you've actually started defining the method you're going to have on that class. And that'll kind of like steer the names that you kind of give it. It's actually pretty hard to describe this in kind of like just verbally without just showing you code. But hopefully you get an idea of, where, how the kind of process goes along. So we have this data input reader, whatever you want to call it, which is responsible for reading the input data. We then have the spreadsheet creator, let's call it, which creates a spreadsheet. And then we have the PDF renderer, let's call it, which basically renders the PDF report. Yeah. So this one method, generate report, inside the report generator, which is a class that we fabricated to stick the whole contents of that main method into initially, has now had that method decomposed into 3 separate classes: data input reader, which reads the dataset, spreadsheet creator, which creates the spreadsheet, and PDF renderer, which renders the PDF or creates the PDF or whatever. And also, when we were doing that, we were migrating across the individual kind of like chunks of method calls or groups of method calls into these different respective classes. We started thinking about whether we wanted to have the class offer more than just a static method, where that method is going to be stateless. In other words, it's not going to have any data members there, which are non-static, so member variables if you like. We were thinking about whether that's going to happen, and we're just going to have a stateless method in the class, or whether the class needs to be something more than just a class, more than just a static method, and it actually needs to hold on to some kind of state. And if it does need to hold on to some kind of state, then we're going to have those member variables there to have that state. Now, the initial reasoning around whether we decide whether we're going to have objects with state or just classes which don't have any state with just static methods, there can actually be a few reasons for that. One can be, do we want to have to package a lot of things up and pass them into the parameters of individual methods that have been invoked? Because if you pass an object with state, then the receiving object or receiving class, once it gets hold of that reference, can access the other things it needs to with appropriate getters. Otherwise, you have to explicitly put the extra parameters on in the method signature itself. So for example, supposing you have a person class, and person has a string, which is a person's name, and an int, which is a person's age, then you can choose to have a method which just takes a person parameter. That's just like one parameter then that you're passing. But you can, of course, still access the name and the age inside that method, so inside the receiver, just by doing person.getName or person.getAge. So it's kind of nice because it means that you've got a less cluttered method signature. And it also means as well that you can add effectively extra parameters or pass extra parameters on as long as you have a getter for it on the object that's been passed in. So for example, say a week later, the person object then has a new method which is to get address, then that's okay. We don't have to add an extra parameter to that method, passing the address in. Instead, we just can access it directly inside the receiver. So person.getAddress. Now again, another aspect of OO is that a good thing to do? There's always a trade-off between the simplicity of the method calls that you're making in terms of the parameters that you are or you're not passing, and in terms of how much knowledge the receiver has about the object that's being passed in. So for example, the receiver having the capability of being able to do getName, getAge, and getAddress, yeah, at first sight that can be a good thing, because it means you only ever have to pass this one parameter, which is a person type. The downside, of course, is that then the implementation of that method then starts to depend on stuff that's been exposed in this person object. So for example, if we decide to take away the getAddress method of the person object, then this is going to then break the implementation of that receiving method. So there's always kind of like a balancing act that you do with OO design. But nonetheless, in the initial stages, we're taking this big method, decomposing it into smaller methods aligned to a particular functional area, pushing those methods into separate classes, and considering whether those classes need to have state or not, which can also be connected to the lifetime of the object, so how long you want the object to stick around for, but that's something else which is a bit more advanced. But at the very least at this point though, we've started to fashion out a very rough kind of domain model, kind of out of thin air, just by using basic common sense, but always starting from that very first embryonic minimal viable product of what the smallest amount of code needs to look like. And again, along the way, we're going to be looking at things like, okay, how do we pass parameters between the different objects? And if we're passing parameters, maybe we need to introduce a new concept for that, so a new class. In the case when we spoke about passing in the different dataset input or data source input, whatever it was called, into the spreadsheet creator. And if we anticipate that we're going to want to change that at some future date, then maybe we actually have an interface for that type. And then the receiving method has a parameter of that interface type and not an actual subclass or an actual implementation of that, because that means we can swap in and swap out different implementations in the future. And also in doing that, we'd also start to think about how we're actually going to create these objects and who's responsible for creating those objects. And then at this point, we kind of start to get involved with thinking about design patterns, which you may have come across. So there are 3 types of design patterns fundamentally, which are creational, structural, and behavioral. And these are basically different ways of being able to structure the code different ways of being able to formulate our classes and objects to be able to shape the design in a way which allows it to evolve in the direction we kind of want it to go in. So, for example, who's responsible for creating certain types of objects? How are those objects going to communicate with each other? Where do we want to have reusability? Where do we anticipate we're going to get the most change to the design? And build in flexibility so that when we change the design, it's going to have minimal impact, that kind of stuff. And moving on from just design patterns, we'd also start to think about layers, for example. So if we're looking at an enterprise application, you'd start thinking about having a presentation layer where you have the controllers in a web application, for example. They're just dealing with HTTP requests and responses, that kind of thing. The controllers are talking to a service layer. In the service layer, sometimes called the business layer as well, you're going to have services which provide methods to do whatever business operations you need to do, and those services are going to in turn invoke repositories, which are in the data layer, which know how to deal with the different relational entities, NoSQL data stores, whatever it is you've got on the back end, those kind of things. But regardless of how advanced we get with things, don't forget where we came from. We came from first principles, make everything as small and as simple as it needs to be, get something working 100%, doing what it needs to do, in the minimal possible unit of code, which is that main method. And then from there, we start fleshing out classes and distributing code across these classes and everything to get a nice object design going, evolve that as we see fit, and then going down the route of design patterns, how that can facilitate better design for us, and then thinking even further down the line about layering if it's an enterprise application. But all of these things, all of these skill sets that you've got in your toolbox, which is basically knowing the basic OR constructs, encapsulation, inheritance, polymorphism, those kind of things, design patterns, knowing how and where to use them, and what trade-offs you have in applying them as you go along, knowing about layering and layered architectures and how you develop those kind of things in your toolbox. They all work together to get you to a fully matured and evolved OR design, which is robust and will do what it needs to do, and could also then be independently unit tested, which is another key aspect of making sure that your classes or objects have this need to stick to the single responsibility principle, so then your system's going to be better testable as well. But all of these things together, no matter how advanced they might be, it all starts with the basics. And the basics are, get a chunk of code going, which is as small as it needs to be, an MVP of what you need to have done, and then start trying to distribute it into a proper domain model. But the confusion can come where you first of all start trying to think kind of the other way around, where you're thinking, okay, so I've got to create a spreadsheet, I've got to create a PDF, I'm going to have to do some input, so I'll just randomly start creating objects for these different things that I kind of think I'm going to need, and I'll stick some code in here to do this bit, I'll put some code in here to do this bit, and then, you very quickly start to tie yourself up in knots, because you've really started by trying to just kind of cobble together some concepts or classes, objects which kind of felt like they might be needed, and then trying to kind of structure them all together to be able to talk and communicate coherently and everything. And it's not the way to do it, in my opinion. The best way to do it is to always start with the simplest possible unit and then evolve it to introduce this kind of extra complexity, which it is if you're creating extra classes and objects and stuff. Let's call it what it is. It is extra complexity, but we're only adding that extra complexity at that point for a reason. And the reason is that it's driven by things like separation of concerns or single responsibility principle and that kind of thing. So my entire point for this episode is that you shouldn't be fazed by having to design an OR system or whatever. There's no such thing really as an OR system. What it is basically is that you have a task to do some code, you get the code into the smallest possible unit it can be, that it can exist and do what it needs to do, and then you can flesh it out into an OR model as you go along. And don't be afraid of all these things, like design patterns and layered architectures and all that kind of stuff. All of that comes with experience, but as long as you take little baby steps along the way and ensure that any changes that you make as you're evolving this design actually have a tangible, beneficial reason to why you're doing them, then even if you don't know all that other stuff about design patterns and layered architectures and everything, at least you'll evolve something that'll be coded in a nice, sensible way. Will probably end up being fairly self-explanatory for anybody who's using it and has to develop it, and you'll end up getting the best possible design that you can write with your current skill set right now. And from there, it's only ever going to get better with experience. So that's it for this podcast episode. If you haven't joined the Facebook group yet, please join that. It's a nice friendly community where you can get help with all things Java. Also check out javaeasily.com, and in particular the courses section, so courses.javaeasily.com, to look at all our different courses that we've got on offer. And until next time, keep coding, stay safe, and speak soon. Bye.